So my first thought on all of these, is can I put it in my calculator, and can I figure this out with just a drawing? Those will get you further than you might expect. Perfect. All right, so that first one. Do the data provide convincing statistical evidence? That is a yes/no question. That yes/no question suggests to me that we're going to be doing a test. So we've only learned one confidence interval in one test. So we're going to be doing a test because it's a yes/no question. And if they're asking, does it provide convincing statistical evidence, they're asking me, like, basically, if I'm going to reject HO or not. In this situation, HO, so company specifications allow for no more than 3%. So HO would be that P equals 0.03, sorry. And then they're worried that it's more than that, because if it's more than 3%, that's a problem. So HA would be that P is greater than or less than. Greater than, because they're worried that it's too much. And at that point, I don't even need to write it. But I'm just going to throw in my calculator. I make the calculator do the bulk of the work here. So I'm going stat tests, one prop Z test. So PO is like your initial assumption, so that's 0.03. And then remember X and N, that's like your fraction. So X is the number of successes, which was, in this case, success is like overweight, but it'd be 40 out of 1,000. You make this arrow point the same way as the one you wrote on your paper. So we thought it was greater than, so we're going to use it greater than. And then we can do calculate or draw. So I get the p-value is 0.0318. So 0.032. Do we agree with that? Like, are we okay there? Getting to the p-value? What did I get? I got 0.032. What did you get? Yeah. Okay. So that's my p-value. I want to compare that to my alpha. Is my p-value bigger or smaller than my alpha? Smaller than my alpha. If it's smaller than my alpha, do we reject or fail to reject? We reject. And if we reject, is it statistically significant or not? It is. So there's kind of like a process there that you got to think through. If I have my p-value, it is less than alpha. That means I reject this, and the test is statistically significant because I showed something was like significantly different. Is it statistically significant? Yes, because the p-value is less than the significance level, so B is correct. So I'm not doing any math, right? I didn't write down any formulas. Like, if I could do it my calculator, I want to, because that's faster. Hopefully eliminate some mistakes too. Question on 1. All right, read through 2. 2 is I think this is like really tricky. It looks harmless, but it's not. Sort of like Mr. Pack. Looks harmless. I don't know if he is. I would be drawing this one would be my suggestion. Front of the I don't know how you knew that meant from what I said, but yes. Okay, so a two-tailed hypothesis gives me a p-value of 0.044. So that's both sides. Add up, so two tails means I added up the left tail and the right tail, and I got 0.44. So how much is in each tail? 0.22. But here's the thing. So let's say we're here, and there's like 0.22 over there, 0.22 over there. So that's where I got my p-value of 0.44 and added those up. It's saying if it was a one-tailed test, what are the possible p-values? Well, one-tailed test, it could be either one, but let's say it's right there. If your HA was less than, what would your p-value be? 0.22. That's what this is. That's like to the left-hand side. If your HA was greater than, which is very unlikely, but it's possible. If it was greater than, how much area is over here? 0.78. So they're both possible. It's very unlikely. That's the 0.78. Why is it 0.88? Oh, they doubled 0.44. I guess. But D is the right answer because you don't actually know which way the test is going to go, lower or higher. If you think a thing is lower, it's probably going to be lower, but it could be. Try 3. Take a look at 3. Try it. I'll give you a second. I'm not doing all of them. I got like 5 or 6 circles. All right, let's look at. I want to go through a little more than just what the question asks, just to like practice other stuff too. 10 years ago, only 53%. We think it's higher today, and we take a sample and find 56%. So what would HO be? 0.53 or 0.56? It'd be 0.53. So this is like the claim. This is the original amount is 0.53. We think it's higher. So what would HA be? Greater than, less than, or not equal to? It'd be greater than. The numbers can't change. Those have to be the same. It's just the O states that we're equal, and the A states we're bigger, less than, small. So then we do the whole test. I don't really have enough data to run the test because I don't know N. But that's okay because they told me the p-value. The p-value is 0.2803. Bigger or smaller than alpha? Bigger, right? So do we reject or fail to reject? We fail to reject. So if we fail to reject, is there enough evidence? Or is there statistically significant evidence? There's not. And there's not because our 0.283 was bigger than the alpha of 0.05. Is that alright? Let's go to number 6 and just put a giant X through it. Don't do that one. What? You're grinding number 6 already? It's got stuff that we haven't learned. You might be able to get it. So I like number 5. I think is 5. Number 6 gets into like 2 proportions. But if there's stuff on comments, hard, let me know and I can look at it and see. Go to number 13. Oh wait, no, go to 12 and cross it off. 12 is garbage. Stupid. Yeah. And then go to 13. I like 13. I'm going to do 13. Alright. Okay, so Audrey sold 88 out of 600 tickets, which is a certain percentage. So it's like 0.14666. Then 7 out of 30 of hers were selected for prizes. That's like 23%. So the question is that far enough away from like the proportion that she sold to think like something was suspicious, like she somehow rigged it for her own sales or something, or is it close enough that you can be like, yeah, that's just sample variance? That's the question. They give me, they don't give me an alpha, do they? Based on the results, is there convincing statistical evidence at alpha equals 0.05 that Audrey selling at least 7 of the 30 is unlikely to have occurred by chance. So at least 7 of the 30 means like this area here. So that hopefully reminds you of like shading one tail of the normal curve. That's what we're doing here. And the size of this area is my p-value. So it's a section like this on Khan as well. So we're going to count how many of these were 7 or more. This is at least 7. So I'm going to go 78 plus 39 plus 15 plus 5 plus 1. That's 138. There were 1,000 total in my simulation. So, what's my p-value? It's the proportion that we shaded. So it'd be this part over here. So what proportion is that? 0.138 is my p-value. Because that's the probability that I get something that weird or weirder. And then if I look down through my answers, okay, and then is that bigger or smaller than 0.05? Bigger, so are we rejecting or failing to reject? Failing to reject, so is there enough evidence or not? No, so that's easy. Then one more I wanted to look at, and I'll certainly do whatever you guys want also, but look at 18. Oh no, there's 2 more I want to look at, I'm sorry. Do you have one? Not that big, it's just best to pretend you didn't say anything. Take a look at 18, try it. Alright, so when we make these little graphs, I'm not sure I've done the greatest job of explaining this part, but the middle number is P. Like that's the, Mr. Shin says 80% of students from Highland North College. P would be 0.8. That's like the claim. And then we might find out our P hat, say it's like 0.9. We think it's like, actually, Mr. Shin, 90% of students go to college. And we shade this little area over here, right? And that area, I'm pointing at that area and saying that's the p-value. So, actually, just with that, I don't know if you have the right answer or not yet, but see if that helps you verify what you put, or maybe want to change your answer. Look at your answers again now that I drew that. So to me, the drawing is like the easiest way to explain it. It's the probability of getting p hat or more if p is actually true. So p hat or more is like the shaded area, and it could be less if we were doing the other side. But the probability of getting p hat or more, or as extreme as p hat, given that p is true. So D is your answer. That's like the definition of a p-value. I'm curious. I'm judging me, not you. How many had D there? How many had D before I did the drawing? Okay, so the drawing helped. Okay, cool. One more, 26. Kind of the same idea. Defining a p-value. So take a look at 26 and see how that goes. For a second, I thought you got up like kind of forcefully. I thought you were storming out of class. Yeah, but enough of this number 26. Should have known. If you were going to storm out, I don't think this would have been the cause either. There's other things I'm sure that have made you want to react. So, P would be 0.83 because that's what the hypothesis states. Random sample is the 0.85. So a sample is always your p-hat. And then the claim is your p-hat.
Oh, I do that.
Well, what were you asking?
So you know what we did? They had an HA and HO. Do we use 0.83 or 0.85 for HA and HO?
Use P. Okay. So then your HA would be like.
Oh, I
Okay.
confused myself because I was thinking we had to use the 85 and the 83. Then we can only use
We use the 85 like in the problem.
Yeah,
not in
exactly.
the-
Right.
yeah.
Right. That's right. Thank you.
Okay, well, I can take it back. I did stuff that was,
Okay. I'm going to sketch it out again. I think that's a good way to look at it. Why, please? So P is here. And that's what the original claim would be. So what number goes there? 0.83. Good. Because that's what the hypothesis states. So that it states more than 0.83 or 83, but the hypothesis number goes here. 85 or 0.85 is our sample, so it's like over here. That's my PS. So this is B. This is B hat. And then we shade this, right? Why am I shading to the right? Because it says more than right here. And so I want to know the probability that, like, I want to describe this area, basically. So if I look at B has the 85% or more part, but wait, no, B's right. Sorry. B has the 85% or more part and the p-value. That's correct. So B is right. How many had B? All right. Is that a question, or are you just still like waving at me? Okay. Really good test questions. Things I look at. I'm giving you the rest of the time in class to work on it, check your answers on Schoology. Let me know if I can help, etc.